Okay, folks, so we're going to look at calibrating the Si5351. 51. So, anybody not familiar with the chip? This is it here. This is the guy that we're using. So this seems to have changed. It used to be 9 kilohertz, I thought, but maybe I'm wrong. And there's different variants. This is what we're using. So we have a 25 megahertz crystal here, and we talk to it over I2C. We're using this library from EtherKit. Works really well. So we go into our Arduino, and I'm going to do this in a number of different ways, or for a number of different purposes. One is to show if you want to create a sketch for yourself, completely new, how you would do it. So we'll do a new sketch. Excuse me. So it has picked up that it's the same board. If not, you'll have to enter that in. And we can copy and steal code from a different sketch here. This is the direct conversion receiver. So if you just follow the documentation on this is what it says to do, and so you basically include these two libraries. That's for the chip itself. This is the I2C library. You create a class for the chip, and you initialize it. It defaults to an I2C, which I can't remember, but I set it to 60 because that's what it is in ours. And yeah, so we'll just go ahead and program this up. So I'm just going to copy and paste from here into the other guy, into the new sketch, and I'll save this actually. So save as Si5351 calibration. Okay, and let's save that. So we've included those. We don't need the TFT rotary encoder. We don't need any of this stuff at all. I'll take this first, and let's get rid of this here. So a couple of steps. One is we're going to create a class and tell it that the chip is at I2C address 660. I'll explain why I'm going with 10 megahertz. So when we look at this here, it basically on the calibration, what they recommend is the easiest way is to measure 10 megahertz signal and scale it to parts per billion. So whatever error that you get, parts per billion, yeah, you can do that, but it's really multiply the error by 100, and you're good to go. So let's go back here. So we have, here's the direct conversion one. Okay, so there's a function here, and it's included in virtually all the sketches to set up the Si5351. So we'll put this in here. I'm going to set the correction to 0. What just happened there? So 0 multiplied by 100 doesn't make a lot of sense. So what happens here is we initialize it. If it's not found, we get a message up the serial port telling us it's not there, and if it is found, it'll tell us it is there. We're setting the correction to 0, so there's no correction. Drive strength, and then we set our frequency, and again, whatever frequency we're setting, we multiply it by 100. And then in our, just copy this, in our setup, all we need is I'll set this to 115,200. That's the default for our Arduino. So in our setup, we do this. In our loop, we don't have to do anything. We just all this sketch is going to do is just put out a single frequency of 10 megahertz for now. And if I haven't made any mistakes, I should be able to send that down to the board. So it's found the device on the I2C bus, and then let's just look at the setup over here. So hopefully you can see this. So I just had a probe basically in the center of the first oscillator, oscillator 1, and it's coming out at, let me just change the gate here to 10 seconds. Firstly, it'll take 10 seconds to update, but it'll give us a more accurate number. So we're at 1896 of an error. Yeah, so 1.8 kilohertz, 1.9 kilohertz approximately. So what we do then is we just simply take that number, so 1896, and we put that into our calibration here, 1896. And let's download that. So that should correct for that error. And let's see what happens when we do that. So again, it's founded on the I2C bus, and then we just go over here to our frequency counter. So hopefully that is coming out somewhat clear. So it's off by 1.8 hertz, because that's 1/10 of a hertz here. So let's actually just change this gate, speed it up a little bit. So you can say it's off by approximately 2 hertz, which is pretty good. We could, if you wanted to, go in here and change this number. But you know, 2, and if you want to by all means do. But you'll find even with changes in temperature and that you know, I don't think you're going to gain anything out of it. But what is useful is to just check it at a different frequency. So we're going to check it at 7 megahertz. So this would be, you know, if we're operating in the 40 meter band, how much are we going to be off by? So we'll just let that compile. It's found the device, and we'll go over here and we'll see it's again off by 2 hertz. So that's pretty good. I don't think you're going to notice on air that it's. Let's just change this to 4. Just. Okay, so for those that want to be absolutely perfect, I think that's pretty good. And let's do this for. Let's go back to the 10 megahertz and see if it has held. There's no reason it wouldn't. but you're not going to notice 1 or 2 hertz on air, one way or the other. So it doesn't really matter. So let that send itself down, and yeah, that's good enough. Even though this is at 10 hertz. Is that right? 10, 1, 2, 3, yeah. So let's do the gate. For anybody who wants to wait 10 seconds to really see how good or bad it has held. So we're off by 0.2 of a hertz. So if you really want to change it, you can go in and change it in there as well. But you're never going to notice it. Okay, so that's how you calibrate it. This is an important number. So if I copy this, and then in any of the sketches that use the VFO, so let's say the direct conversion one here, when we call that function to when we call this Si5351 function, you need to put that number in there if you want it to be really accurate. And it will, you need to do that in every sketch where you use excuse me, in every sketch where you use the Si5351. And once you do that, you're going to be within a couple of hertz of where you need to be. It is unique for every system, and but once what you only need to do this once, and then it should hold from there on in. So I hope that works for you, and excuse me. If there's any questions or anything, you can just put them in the comments below. Okay. Cheers, folks. Thanks.